Given arcsine of x equals natural log of y, then find dy dx. Find the derivative of y with respect to x. Okay. So we have kind of an equation on both sides. And we could isolate y by itself. We just take both things to the power of e. But I have no idea how to do the e arcsine of x. Yeah, I don't know. So we're going to do implicit differentiation. Plus it says so in the title. So we have natural log of y equals arcsine of x. I know I didn't really change much. I just like y's on the left. It's part of life. I grew up that way. Okay, take the derivative of both sides. Derivative of natural log of y would be 1 over y times dy dx. Yep. Because chain rule. The derivative, so you take the derivative of the exterior, natural log of y, so it'd be 1 over y, times derivative of the interior, derivative of y would be derivative dy dx. So f of g of x, brackets, parentheses, equals f prime of g of x times, do I have enough space? Not enough space. Almost, sort of, kind of. Okay. Now, we need the derivative of arcsine, which is 1 over 1 minus x squared square rooted. Times derivative of x with respect to x, which is 1. So, is this actually easy? Dy dx equals y over 1 minus x squared square rooted. Okay. That wasn't too bad. It's even a possible answer. Okay. So, there's a couple tricks here. So the first one is you have to know that you can take the derivative of the left side. Take the derivative of the left side, you treat y as a function of x. So you're like, y is y of x. And then you can use then it's a little bit more obvious how you can use the chain rule, f of g of x. Then you have to know the derivative of the arcsine of x. That's basically just memorizing. You learn it more to do a trig substitution, go the other way around with integrals. But I guess if you know doing the integral, you should know the derivative as well. And the derivatives, so you have arcsine of x, these are derivatives, equals 1 over 1 minus x squared square rooted. And the way I remember that as a mnemonic point of view is sine and sine. I know one is S-I-G-N, one is S-I-N. It's okay. I think this means bow. Does that mean bow? Like sinew? I don't know. Doesn't matter. The idea here is mnemonic. Sine, sine. The sine is with the x squared. Then the other one you have, I should have changed colors. Secant of x, I remember it as, well, it's the other one. Whoop. You get x squared minus 1. So this is the sine is with the x. Secant is the sine with not the x. And secant is 1 over cosine. Then you get, guess I should change colors again. d dx, arctangent of x. And then I just remember that these two are added. X squared plus 1 square rooted. And you might be thinking, what if there's not a 1 there? Well, you can then, if you have a number there that's not a 1, like you'll usually want it to be a square, like 4, 9, 16, 25. What you do then is you can then pull that factor out, and what you get left with it is the x squared becomes like some value a times x squared, or x over a squared. And so you can always rearrange it so that there'll be a 1 as long as you have a square here and a square there. So key thing to remember here, You can take the derivative of the left side, which I guess in this case is actually the right side, and you can take the derivative of the other side. You have to know your arcsine rules, inverse trigonometric integrals, and yeah, rearrange, find the answer. Not too bad.